morning. My name is Lubor Košťal. I'm from the Center of Biosciences of the Slovak Academy of Sciences in Bratislava, Slovakia, and I will chair this session. So welcome here. And I will start with a small announcement. Yesterday during the session at 3:15, somebody exchanged the pointer of the organizers for his own. So if you know about the person, because there is a USB part of it that is not matching that from the other one. So even that person, it's in her interest or his interest to find the proper one. Okay, and our first speaker is online, and it's Alex Johnny. I hope he is there, and we are looking forward to your presentation.
Hi. I hope everybody can hear me.
Yes, we can hear you and we can see your presentation. So please start.
Okay, great. Okay. Hi, I'm Alex. I'm a PhD student at the University of Bern. And today I'll be talking about an experiment that I did for my PhD, where I used artificial moving cues to encourage ramp use behavior in laying hen chicks. So ramps are this little structure that you see here that connects the different tiers of aviaries, and providing them during the laying phase has been shown to improve movement between tiers. And similarly, providing them during the rearing phase, the early life period that is a critical development period for the laying hen chicks, also has been shown to increase inter-tier transitions. And additionally, providing ramps during the rearing phase facilitated an earlier access to elevated surfaces. So young chicks get earlier access to complex three-dimensional space. And this is something that has been known to improve the spatial cognition in laying hen chicks. And similarly, increase in inter-tier transitions can be considered as a form of increase in voluntary exercise. And especially in early life, an increase in voluntary exercise is something that is known to improve neurogenesis in hippocampus, as well as improve spatial cognitions in humans and rodents. So an early life increase in ramp use is something that can have potential implications on the welfare benefits of on the spatial cognition of the birds. And given the long-term and welfare benefits of long-term and short-term welfare benefits of the ramps, it is important to consider how do you encourage this behavior. So this video here shows how young chicks respond to tapping motion and sound, and how this is routinely used to encourage feeding behavior in birds. And similar to how the birds respond to this tapping motion and sound, birds also respond to a lot of innate preferences that they have, that they prefer objects that are moving over objects that are stationary, and of objects that are moving, they prefer objects that can propel themselves and things that show speed changes. And they also respond to social cues that helps them recognize and bond with their mother and conspecifics. And these cues help the birds. This cues is something that can help to encourage the positive behaviors in birds. With this, I come to my aims, where I plan to investigate if the use of artificial moving cues can increase ramp use in early life of laying hen chicks. And the second aim is to assess if differences in early life ramp use brought about by the cues can influence spatial cognition of the birds. And for the third one, it was to see if individual differences in early life ramp use can influence spatial cognitions at a later age. And for this, I used small-scale pens in an experimental setting. I used 16 of them that housed 22 birds each, and I had 4 treatments, of which 3 were moving cues and 1 was control, which led to a sample size of 4 pens per treatment. And artificial moving cues were applied as intermittent 4 minutes bout dispersed all throughout the daylight period and accounted for 6% of the total light period. And the cues were placed on the first tier until day of age 3, so as to induce a familiarity towards the cue, after which they were moved to the second tier. And from day of age 4, the birds got access to ramps and mirror, until which they were constrained to the first year. And this is how my moving cues look like. So this is the first one. It's called LED. And in the LED cue, I had an LED strip that was programmed to simulate the motion of a small moving object. And this here is my second cue that's called the B cue, and in which I had a beak-shaped object that moved up and down to create a vertical tapping motion as well as a tapping sound. And this is my third cue, and the third cue is called the hen, where I had an hen-shaped object that moved to and fro to create a moving hen. And for each of, and now to quantify the rambu's behavior in the pens, I counted the number of transitions that happened using ramps. So the transition is defined where the bird moves from one tier to another. And besides using ramps for transitions, birds can also actively use ramps that does not end up in the transitions, like where the birds can walk or jump on and jump off to the ramps, but doesn't involve a tier change. So I counted all of this as well and called it active use of ramps without transitions. Now coming on to the results. So for the transitions using ramps, what I found was an effect of treatment where the big birds performed 1.5 times fewer number of transitions than the control group. Now coming on to the active use of ramps without transitions, what I found was an effect of interaction between treatment and day of age. And when I look into it closely, I see that LED birds performed more active behaviors with increasing age, while for the rest of the groups, they all performed lesser number of active behaviors as they increased in age. And now I come on to my second aim, where I wanted to see if the increase in rambu's brought about by the cues could influence the spatial cognition of the birds. And for that, I did a Hallboard task. And the basic gist of Hallboard task is that the birds have to learn configuration of 3 rewarded cups out of a total of 8 cups. And it happened in 3 different phases. The first phase being the cued phase. And in the cued phase, you had these 3 cups that had the reward, and they had a color cue associated with the rewarded cups. So 1, 6, and 8 are the rewarded cups, and there are 10 trials to learn it. And then I come after the cued phase, the birds went on to the uncued phase. So in here, the reward configuration remained the same, but there is no longer a cue associated with it. And after 20 trials of uncued phase, all the birds that reached success criterion is subjected to a reversal task. And the reversal task, the configuration of the reward is changed. So in the uncued, if it was 1, 6, and 8 that was rewarded, when you come to the reversal, it is 5, 6, and 3 that's rewarded. And from Hallboard task, the good thing is that you can get multiple indices of spatial cognitive memory, one of which being the reference memory or the long-term memory. So in here, the reference memory measures the ability of the birds to discriminate between weighted and unweighted cups and learn its configuration. So it has information that is relevant across multiple trials, such as location of the reward. And there are some cups that are rewarded in this arena. So all this information are trial independent. And it's calculated by taking the difference of all visits minus the visits to weighted cups. And the second measure that you get is the general working memory or the short-term memory. And in here, it measures the hen's ability to avoid holes that she has already visited within a particular trial. So the birds have to remember that she has visited cup 3, 4, 5 in a particular trial. So it holds information that is relevant to that particular trial only. So it is a trial-dependent measure. And it's calculated by taking the difference between unique visits and all visits. And the one thing that you have to remember is that higher the score means more errors the birds have made. That means lower the memory index. And now what I can do is take both of these memories, and then I can look at how this differs for treatment for all the 3 different phases, which is what I did. And now to summarize what happened with all the analysis, that for the Hallboard task and how it relates to the treatment, there was no difference in spatial cognitions across the treatment, which also makes sense because we didn't have so much of rambu's behavior changes that was brought about by the treatments or associated with the cues. So with which I come on to my third aim, where I wanted to assess if individual differences in RAM use frequency in early life could influence the spatial cognition of the birds. And now to get this individual level RAM use behavior, I had color marked individual birds in my pens, and I remarked them across throughout the age. And then I counted all the RAM use behaviors that they performed over 7 observation days spread across the first 8 weeks of their life. And this here is a graph that represents the RAM use frequency of this individual, so that's summed for all of their life. And you can see that there is some amount of variation between these individuals. And now to see how it relates to this Holbow task measures, I took 10 individuals with the highest RAM use and 10 with the low RAM use and performed an analysis. So this here is the results for the reference memory. So I have to remember this is a long-term memory, and it's for all the phases. And if I am to look at it statistically, what I see that I only have differences in the reversal phase. And where the high
John,
RAM
you
users
have
made,
2 minutes to finish.
where the high RAM users made a higher number of errors compared to the low RAM users, only in the reversal phase, and there was no differences in any other phases. And now coming on to how this is a graphs for the general working memory or the short-term memory for all the 3 phases. And it's again the same colors, with the blue color being high RAM users and red color being low RAM users. And if I'm to look at it statistically, what I see is that low RAM users perform more number of errors than high RAM users in the queued phase. So now on to conclude all the things that I was saying, as that queues only had a slight effect on the RAM use behavior. And probably because of this, I also did not have much effect of the queues, on the spatial cognition. And what I found that was interesting was this link between early life RAM use frequency and the spatial cognition, where the high RAM users had better learning scores in the queued phase. And when it came to the reversal phase, which is a measure of cognitive flexibility, they had more errors. So which makes me think that high RAM users might be fast learners that has less flexibility. One additional possibility that I like to think about is also how the differences in RAM use as well as the difference in spatial cognition might be driven by inter-individual differences. For example, you have behaviors such as exploration and activity that can influence RAM use behavior. And these behaviors are known to correlate with cognitive traits such as speed and accuracy with which decisions are made, and how flexible are individuals in this decision-making process. So a correlation between behavior and cognition might be something that drives this difference in RAM use and spatial cognition. And with which I thank you all for listening, and I thank everybody who helped me with this project and my funding agency. Thank you so much.
Okay, so thank you for an interesting talk and a good timing. And now it's time for questions. There's the first one.
Thank you, Alex, for the very interesting talk. And I love that you're working in the pullet area. We need so much more knowledge here. This is Suzanne Millman from Iowa State University. And I was particularly interested in the early stages of your experiment. So where you were training them in the first few days. From your photo, it looked like the ramp was quite a high, it was quite a high slope and quite a high distance. And I was curious to know if there are problems with the new chicks actually falling off, or whether you do any training at lower elevations to begin with.
I think the picture is a bit misleading because the ramps were only 35 degrees in angle. And in terms of the length, it was around 1.3 meters. But to answer your question, I didn't observe the birds falling down. And also, interestingly, what I also saw with my experiments is that the birds wouldn't start to immediately get up the ramps and go on to the top tier. Like you had this initial phase where I put in the ramps in the first week, where the birds were exploring and then doing this active behaviors on the ramps, but not really going all the way up to the second tier. And I already see the transitions getting picked up from the second week or so. And this is something that I saw for 2 of my experiments in a experimental setting, and also something that we saw in a commercial setting. So it kind of means that I think the birds kind of are slowly progressing in terms of how they use the ramps, and which is something that I think is helping the birds not to fall down or not to get lost or things like that.
Thank you.
Okay, Bas.
Bas Rodenburg, Utrecht University. Thank you, Alex, for a very nice talk. I was wondering about those high ramp users. Did you do other personality tests that might reflect indeed that they might have different personalities? Because in terms of your results, it seems to point in that direction. Can you say a bit more about that?
I wish I did, but then I haven't. I don't have any other measures on personality other than cognitive traits. Yeah, I think this would be something interesting to do, to look at, like, I know we have more and more research coming up on individual level for the birds. So I think this would be something interesting to look in terms of ramp use and in terms of cognitive traits.
Thanks. Yeah.
Okay, thank you very much. I think that it's time to proceed and our next speaker is Lucille Dumontier. Floor is yours.
Hi everyone. How do I have to adjust that? Right. I hope you can hear me better now. So my name is Lucille Dumontier. I'm a PhD candidate at the Norwegian University of Life Sciences. And today I will present you part of my work on the effects of the early life environment on laying hen spatial cognition. So to give you a bit of background for those who are not familiar with laying hens, chicks are hatched in hatcheries before being transferred to the rearing facilities, and then they are being transferred to the laying facilities right before the onset of lay, so when they reach 16 to 18 weeks of age. And there are different types of environment they can experience. They can be housed in cages or in aviaries. And so we were interested in looking at how the complexity of the environment during the rearing phase would affect their cognition during the laying phase. So what we did was that we reared some chicks in cage or in aviary. You have here a picture to illustrate how it looks like. I don't know if you can see that thing. Yes. So on the left-hand side, you can see the aviary hens. So they were able to navigate between the different tiers of the aviary, to have access to the floor of the arena, and to perch on the front of the cage. And on the right-hand side, you have the cage hens, which were kept inside the aviary row for the whole rearing period. And so these two environments present two distinct levels of complexity, the cage environment being much less complex than the aviary system. And for the laying phase, we housed them all in furnished cages. That's what you can see here on the pictures. They were housed into cages per group of 4. And they had access to 4 different perches, 2 nest boxes, and 2 dust batting platforms. And they could navigate between the 2 parts of the cage by a small opening between those 2 cages. And so to access their cognition, we decided to use a whole ball test. Now we are all familiar with the whole ball test, thanks to Alex's talk. So it's an interesting task because it allows to quantify spatial cognition and learning, and it can assess different aspects of memory. And so we based our work on the fact that complexity of the rearing environment has long-lasting effects on spatial cognition. And we predicted that the cage-reared hens will show lower cognitive performances during laying due to the fact that they experiment a less complex environment. So what we did first is that we habituated 2 hens per cage to the task. So 32 cage-reared hens and 32 aviary-reared hens. And so we first habituated them to the cups we use for the reward. So you can see the cups here. That's a picture of the arena. So we started by habituating them to the cups in their home pen. And after that, we habituated them to the arena. So during the habituation phase, all cubs were baited with one mealworm to increase their motivation to navigate in the arena and explore. And at the end of that habituation phase, we selected the best performing hen, which was necessary because if they do not eat the worm during the habituation phase, we can't really assess their cognition later on based on the number of worms they eat. So I use a slightly different version of the whole board than Alex, so we just present what I did. We studied the test at 35 weeks of age with an uncued phase, which lasted for 12 days. So you have a view from the top of the arena here. We baited 3 cubs out of the 8, and the hens could start the trial either in the A or B position. The idea was to avoid them to learn a fixed route and so to make sure they learn where the baits were. They were tested twice a day for all the phase of the test. And after 12 days of uncued phase, we switched to acute phase, for which we keep the same configuration of baited cubs, but we added additional cues. As you can see, we turn in red the plywood square, which was under the cubs, to give them additional cues and help them find the baits. We then switched to another training phase, which was the same configuration of baits, but we removed the cues. And we switched finally to a reversal phase where we changed the configuration of baited cubs. So for the analysis, we averaged the parameters per block of 2 consecutive days. And we looked at 4 different variables. So we looked at the latency to find the first bait. We looked at 2 different working memory ratio. So the working memory ratio and the general working memory ratio, which are short-term memory, trial dependent, and show their ability to avoid revisiting cubs. And we also looked at the reference memory ratio, which is a long-term memory ratio, which shows if they can discriminate between baited and unbaited cubs. And so we looked at those variables for each phase and also for the transition between each phase to look at how they will react when we change the different parameters in the arena. So what if we look at the latency to get to the first baited cub? So you have on the x-axis the block and on the y-axis the latency to find the bait. We can see that over time they get faster to find the first bait. We have a bit an increase of latency to get the first bait during the first block of the acute phase, which might be due to a neophobic reaction and when we introduced the cues in the arena. But we can see that they get really fast at the end to find the different baits. And we can also notice that the aviary real hens, which are in red, are much faster than the cage real hens to find the first bait. Now, if we look at the reference memory ratio, so this is a ratio. So contrary to the last presentation, a high score indicates a high memory and a low score, a lower memory performance. We can see that their ratio increase for both groups across time, but we don't have so much of a treatment effect, except for the acute phase where we have an interaction effect between the rearing environment and the trial block, with the aviary reared hens starting with a higher reference memory ratio than the cage reared hens. But now if we look at the ratio, it appears that it's not so high for most of the phases. It's ranged between 0.4 and 0.6. So at first look, it could seem that they do not learn where the baits are, and that could be the end of the story here. But it's a bit more complex than that. Because if we look at the general working memory ratio, which is the ability to avoid revisiting cubs, we can see that we have a drop of performance between the overturning and reversal phase for both groups, which means that during the first block of the reversal phase, they revisit more cubs than they did during the last one of the overturning phase. So it seems that there's something going on at that time. And if you remember the timeline I presented you earlier, we changed the configuration of cubs at that point. So it could be that they learn where the cubs are and they get confused by the fact that we changed them. And now if you look at the working memory ratio, which shows also the ability to avoid revisiting cubs, but only for the baited one, we can see that we do not have that drop in performance. So it seems that they revisit more the non-baited cubs than the baited cubs. So now to sum up a bit, we do not have so much of a treatment effect as we might have seen in the different graphs. So it could be that the environmental complexity during rearing did not have so much long-term effect on the cognition, but it might also be due to the selection process of the hen prior to the test. If you look at the data from the habituation phase, we can see that the hens we selected had a much higher number of worm eaten which makes sense because we based our selection process on that variable. But if we look at the hens which were not selected, we can see that the cage-reared hen in blue here ate much less worm than the aviary-reared hens. So at that point, it's a bit hard to know if they eat less worm due to more fearfulness, or if they just do not get the fact that they have to get the worms from the cup, and this could be cognition related. So now to conclude, we saw that the aviary-reared hens were faster to find the first bait. We had no strong effect of the ring environment on memory performances, which might be due to the need we had to select birds for the test. And I think that increasing the cost within the cups might show clearer results, because if you remember the picture from the arena, it's easy for the hens to go to one cup from the other and just check on their way. And I think that we might have more interesting results if we could increase the cost to check the cups. So that's all for me. I would like to thank my supervisor and the MSCA for funding that work, and the Chicken Stress Network, and you all for your attention. So thank you.
Thank you for a very nice talk and good timing. And there is time for questions, please.
Hi, Saskia Kliphuis, Utrecht University. Thank you for your talk. I really like that you showed the graph at the end about the habituation phase in the selection process. I'm wondering if you would have done this experiment all over again, would you make a different decision in this selection process, since there seemed to be some effect there between the different rearing systems or housing systems?
Yeah, the thing is, it's a bit hard to, since the whole board is really based on the fact that they have to find worms in different cups, it's hard to pick hens which do not eat the worm from the task. I think that maybe habituate them for a bit longer to the task, and maybe with other conspecifics for longer time, so they get more confident, and by watching the other eat the worm, they might get more confident, and we could maybe see more difference on that. So I think if I had to do it again, I would try to habituate them in pair or 3 of the same cage a bit longer and see how it goes after that.
Okay, thank you.
Hi, Maya Makakam from UC Davis. Thank you for this excellent talk. I have a question about just cognitive testing in general. And I think this is maybe kind of because it's piggybacking on another study that used the whole board task. So the whole board task only looks at one aspect of cognition. And you alluded to this a little bit at the very end of your presentation when you talked about their ability to even see the cups or kind of figure things out. Are there kind of other components of cognition that you think might be really interesting to look at looking forward?
Yes, so what I did for a second part of my project was to look at their ability to perform a detour, which is also interesting in the fact that you don't need to make them learn anything. It's really just a pass or fail type of task. And it might also be interesting to look at their cognition like in the 3D space, so how they can orientate in 3 dimensions, but I do not have like a specific idea on how to assess that at that point.
Hi, Mathilde Coutin from Aarhus University. It's a bit more of a general question, but do you think that increased cognitive ability is actually beneficial for welfare, considering that animals may have poor raising environments? Do we actually want them to have good cognitive ability?
Well, that's a good question. I think that maybe increasing cognitive abilities to a high extent might not be beneficial, but it's important for them to have at least the bare minimum so they can navigate their environment, especially if they're like in aviaries or free range system, they need to find resources to orientate themselves. So I think it's important for them to have, yes, some good cognitive abilities to at least perform well in their environment.
Thanks, Mike Toscano, University of Bern. Also agree, you have a great talk. So we all wanted cages to be low memory, but I was curious, are there specific aspects of rearing in cages that you think are would where the animal would develop poorly versus in the aviary, like the navigation ability. I'm really kind of curious, what specific things do you think are not developing? And could it be that if you were to do a different type of test, you would see about memory, that you would see different results?
So the idea was that in cages, they don't really have to find any resources. They're in a cage, they have like a feed through going inside, and they don't have to experience so much. I think the idea was more that in an aviary, they can develop much more abilities than the cage, and that they could learn better the task than the cage with hands. I hope that answers the question.
Okay, thank you very much. It's time to move on, and our next speaker is Siga Rasmussen. The floor is yours.
Okay, thank you for the presentation. I am indeed Siga Rasmussen from Aarhus University. I'm a PhD candidate, and I'm going to talk a bit about the first study I did on the effect of age and walking ability on the outcome of certain fear tests in broiler chickens. Now, just in case we have someone in the back sitting there thinking, I don't know what a broiler is, and at this point I'm afraid to ask. I'm here for you. Broiler are chickens that we keep for meat. So there you go. Now, what is it like to be a broiler? Well, I've asked them, they tend not to answer me, but from an outside perspective, it means certain things. First of all, it means that there's been some selection for rather rapid growth. So just within 5 weeks' time, they go from a very small chick size to slaughter weight. So yeah, they get very big, very fast. Another point is, as a broiler chicken, you need to not mind roommates, and many of them, because they're kept in rather big flocks in just one house. So they can be tens of thousands of birds in just one broiler house. So they tend not to have that much room to run around or move in general. This environment in which we keep them tend to lead to some welfare concerns, as with many other farm animals. Luckily, we have many great welfare assessment protocols. And in recent years, there's been an increasing interest for also the emotional states of the animal, to be able to measure this. One way to do so is through fear tests. So that would be the measure of a more negative emotional state. There exist many fear tests, but what a lot of them have in common is that they kind of rely on the bird's ability to either withdraw in case they're scared, or approach in case they're not that scared, whatever stimulus we present them with. However, we know that broiler chickens tend to suffer from walking impairments. So one might imagine that that could affect the ability to live up to the criteria of the test. This has in fact been shown by Vastal and colleagues, who made a brilliant study showing that animals, broiler chickens, would express less fear according to a touch test when the gait score increased, meaning when walking ability decreased. I'll come back to the relationship between gait score and walking ability in a minute. So we thought that this was rather interesting and thought, hey, we can try to look a bit more into this. So we wanted to investigate if age and walking ability affected the outcome of two other validated fear tests. As I mentioned, there are many fear tests. We chose to go with the stationary person tests and the novel object test. And we hypothesized that with increasing age and decreasing walking ability, we would see lower levels of fear as measured through these two tests. And this builds on the assumption that with increasing age, we see decreasing walking ability, since this has been shown in numerous other studies. So we went to 2 Danish conventional broiler chicken farms, and we collected data for almost a year. We visited 6 consecutive flocks per farm, so that would make 12 flocks in total for the mathematicians in here. And we went to each flock 3 times. The last visit would be just a couple of days before slaughter. Usually they would be slaughtered around day 35, 34. And all of these flocks consisted of the fast-growing Ross 308 hybrid. Now, when we went into the broiler flock, the first test that we did was the stationary person test that supposedly measured the fear of humans. So the observer would go to 10 predetermined locations in the barn, stand, start the timer, and every 20 seconds count the number of chickens within 1 meter's distance for 2 minutes. Hereafter, we would perform the novel object tests. The fear of something novel, or can also be signed as a test measuring more general fear. In this case, it was the fear of sport or volleyballs. So we used a very colorful volleyball, placed it in the same 10 locations, and measured the number of birds within half a meter's distance every 10 seconds for 2 minutes. Finally, having tortured the birds enough, we decided to then test their walking ability. We did that in 6 different locations, and the procedure was always the same. We will start off by dimming the light to avoid causing panic in the flock, then carrying in a mobile catching pen, fence in about 20 birds per location, turn the light back on again, and then make them go 1 by 1 and assess their gait. We use the Bristol scale that goes from 0 to 5, 0 being a perfect normal walk and 5 being complete lameness. So what we found was that, non-surprisingly, with age, we saw decreasing walking abilities. A bit surprising, though, was that we actually did not observe that many birds that had a gait score 3 and above compared to other studies. But nonetheless, we did see that the walking ability did in fact decrease with age. So regarding the effect of walking ability on the fear response as measured through the stationary person test, we saw that there was a significant effect, but this effect depended on age. So for the first age, this kind of lived up to our hypothesis that with decreasing walking ability, we saw decreasing fear levels. Then something weird happened, because then we saw the exact opposite at age 27. And then it turned around again at the latter age, just because it's not supposed to be easy, apparently. When we try to think a bit about, okay, why is this? Well, first of all, I'm going to allow myself to look a bit away from the first age, simply because they walk so well at this age. So maybe this doesn't, at least for now, make so much sense to dwell on. But for age 27, the difference here between that and the last age may be that when we started the test, at age 27, we rarely saw any birds already within proximity of the observer when the test started, meaning to not be fearful, they would have to approach rather than avoid. So thinking, okay, I can't, let's just go with the argument, I can't really walk, so I'm not going to approach you, I can't. We would say, okay, they're more fearful. Whereas for the last age, there were usually birds already within proximity when the test started. So here they would have to avoid rather than approach. This might be one explanation for this result. Now, for the novel object test, again, there was a significant effect of walking ability. And again, it depended a bit on age. So for the first 2 ages, we saw that with decreasing walking ability, we had an increased fear response. For the last age, the fear response did increase a bit, but not that much, especially compared to the other ages. Again, here, because it was not really what we expected, we would expect that walking ability would decrease the measured fear level as according to the test. But like the tests, the stationary person test at age 27, what we saw here at almost all ages was that when we put the novel object down, no birds will already be within, or it was at least rare that birds would already be within proximity. So again, they would have to approach rather than avoid. So to conclude, age and walking ability did seem to have an effect on the outcome of these two tests, but the effect depended on the test and the age, apparently. So this means that we can maybe make false assumptions about fear levels in broiler chicken flocks with walking impairments. Of course, the study, the data collection is done, the tests are done at flock level. So it's not a one-to-one relationship between a chicken that does not walk very well and its fear level. So of course, this has its limitations that we need to take into account. But there are also many other possible conditions that could affect the outcome of these tests. We suggest that motivation and space availability could also have an effect and would encourage future studies to look further into this. Thank you very much.
Wonderful talk, wonderful timing. Time for questions.
Thank you. Very interesting talk and results, and intriguing results. Frank Tertus from Belgium. Is it necessarily a false test outcome if the outcome of the fear test is related to the walking ability? Maybe there's some emotional prioritization, and if you are in pain as a chicken, maybe you've got less time or less interest to be fearful. And maybe therefore it would have been interesting to include a fear test in your sample of tests that didn't require locomotion, like the tonic immobility test. Have you considered that, or any thoughts about that?
Thank you for the question. Definitely. Well, I've been thinking about it after data collection was done. As it is usually the case, you come up with many great ideas. But yes, it would have been very interesting to, for example, include the tonic immobility or just physiological measures. That would be a bit hard on a commercial farm maybe, but for another study, because we cannot know necessarily that it's a false result. In theory, you could be more fearful because you're in pain as a bird and thinking, oh, maybe I can't, get away if something comes. Or you're just kind of laying there and figuring out, oh, these people not really harming me, nothing bad is going on. I don't have to, it's fine. So definitely, I guess this study just suggests that we should look into this and we should take these conditions into account and realize that these tests are situated, and just again look more into what is going on, what do we measure.
Just one short note, I'm afraid that even tonic immobility requires some motor skills, and that could be affected by the deterioration, isn't it? Okay, next question, please.
Sabine Gebhardt from Bern. I have a very similar question because I wanted your opinion. Do you think this test measures fear at all? Because you could standardize things. Maybe you would now say, okay, you have to keep density constant, the hybrid constant, the age, and check the mobility of the birds. But if you could all keep that constant, do you still think that this test would be valid to measure fear? Or would you say, oh no, stay away from this test at all?
I will thank you for the question. I will not throw the test all out the window and say this cannot be used at all, but I think there can be other things at play here. Even if we standardize everything, there is motivation, curiosity, all of those things that can also definitely play a role. And also birds could maybe express fear in other ways than running away, even if they're capable of doing so. And they are afraid, they might respond differently. So I don't necessarily think that the test cannot be used at all, because we do see when you go into a flock, it's been very clear to me, if we had a very scared flock, and especially at the age where they had a good walking ability, they would all be at one end of the barn. And I would definitely not see any birds within proximity. And I think it could be a good sign of fear, but I would advise caution when interpreting these tests for sure.
Before that question, there is, not forget about our online colleagues. There is a question from Serge Alindekan, I'm sorry for pronunciation, taking into account your study results, what would be your recommendations for improving standardized field tests on commercially reared broilers?
Yeah, that's a very good question and a bit of a tough one, I have to say, because first of all, I would very much like, and I have dedicated most of my PhD studies to just look further into how all of these conditions can affect the outcome of the test that we use. So I think that's the first step, to figure out what can we standardize the conditions in a way, and then go from there and see, okay, can we then make any changes so that we measure fear more accurately maybe.
Thanks, and very short question from Mike and short response.
Mike Scano, University of Bern. Would there be any benefit to actually doing the gait assessments on the animals immediately around you during the novel object test or the person test? So to actually assess those animals rather than go back and get another subgroup.
Definitely. I mean, again, if we had a more one-to-one relationship, okay, that bird has that gait, but it can be rather difficult, I would say, especially when at ages where the birds kind of tend to just flock around the object, to be able to both count the birds and gait score them and know, okay, that's the bird I just looked at, because it's a sea of white sometimes, and so it can be hard to kind of make sure that you track the same bird. But if you are able to do so, maybe through camera observations or something, that could definitely be a benefit as well.
Thank you very much. It's time to conclude. And our next speaker is Ariane Straatman.
Hi, everyone. I'm Ari Straatman. I'm a postdoc at the University of Bern, working in Mike Toscano's group. And I'm going to present a study that was the basis of the study that Alex presented earlier in the session. And it's about laying hen pullets in rearing aviaries with rams. So along with the trend of keeping laying hens in non-cage housing systems, research has been looking into the welfare benefits and problems of aviary systems. And in these systems, as you can see, the resources are distributed on different levels of the system, and the birds have to navigate vertically in the system in order to have access to these resources. And this vertical navigation in the system is associated with problems such as falls and collisions. And this is as a consequence how research has been looking into how to overcome these problems, and studied the effects of rams. So you see these structures here in order to help overcome or help actually moving in the systems. And it has been shown that rams in laying aviaries reduce keelbone fracture rate, frequency of falls and collisions, prevalence of footpad problems, as well as hesitancy to transition. The studies have been done on adult birds, but there is a phase before that, which is called the rearing period. This is the first 18 weeks of a bird's life. And this is a period that is considered to be very crucial, because the birds learn in these first 18 weeks everything that they need later in the laying environment. And particularly for laying aviaries, aviary systems in general, it's important to promote the development of behaviors and skills that are needed to navigate in a three-dimensional space as an aviary. And skills that are included in the development of this first 18 weeks is skills that are related to the cognitive as well as the physical development, as the birds have to be able to estimate distances between tiers and perches. For example, they have to remember where the different resources are located, and they have to be able physically, in terms of bones and muscle development, to overcome distances. So this is why research has been also done in rearing aviaries in terms of rams. And most of the studies have been done in single tier systems and also in experimental settings. And these studies have been found that if you have rams in the rearing period already, that would lead to more use of elevated structures, less hesitancy behaviors during transitions, as well as has also long-term benefits into the laying phase. However, until this study that we conducted, we didn't know about the effects of ramps in rearing aviaries itself. So this is why we decided to investigate the effects of ramp access in rearing aviaries on moving behavior of laying hen chicks. We predicted that if we provide ramps in the rearing aviary, that this would lead to an earlier and better use of the top tiers. And this is then why it would lead to more even distribution in the system and thus a better access to resources. And we also predicted to find more transitions between the tiers if we have ramps provided rather than no ramps. The study was conducted in a semi-commercial rearing barn. As you can see here, we have the barn split up into 2 barn sites. For each barn site, we have 4 pens available, and the birds also have access to a winter garden. The barn site differed in the rearing aviary that was installed in the pens. We used 2 consecutive flocks. And had for each flock 600 LSL chicks populated per pen. This is how we assigned the treatments. So we had 2 pens per barn site that were left as a control group, so just the aviary as it was. And in the other two pens per barn site, we had ramps installed in the aviary. The ramps were installed in a way that the birds had a continuous vertical path within the aviary, so that the birds were able to walk between the tiers rather than jump and fly in order to move vertically. The chicks were kept on the first tier after population was 1 day of age for the first 10 days. And after that, the aviary was opened and the birds had access to the whole aviary, the litter area, and the ramps. So this is a schematic, like a side view schematic of one of the rearing aviaries. You see in gray, the bars, these are the tiers. So you see that here you have like 3 tiers, and with the middle tier being a bit offside, like on the side of the other 2, you have the resources here in yellow, the feeder line. You have in blue, the drinker line also on top, and in black, the purchase. So this is how a control pen would look like for that aviary. And then this is how we installed the ramps. You see like a structure here as well as here. So the birds were able to walk from this first tier to the middle tier and then up to the top tier. So the other aviary looked like this. You have more like of a stacked kind of aviary. So here again, the 2 tiers. We had additional surface area just to promote enough surface area in order to populate these 600 chicks per pen. But also here, the resources are distributed like on the first and the upper tier, as well as purchase and drinker lines. Here again, the control group. And if we included the ramps, this is how the pens would look like. So here you have ramps on both sides of the aviary, and the birds can walk between the tiers basically. The data collection mainly included video recordings, and we looked at 2 different response variables. So the first one was the number of birds on the top tier. And the number of birds on the top tier was counted at these different weeks of age, 3, 4, 5, 8, 11, and 15 weeks of age. And we counted the birds in standardized area within this, the grid area. The other variable was the number of transitions that was counted at 3, 4, 8, and 14 weeks of age. When the transitions occurred in the pen where we had the ramps included, we distinguished whether this transition was done with or without a ramp. And also here we had standardized areas where we counted the transitions, and just to make it comparable with, just to have a good comparison to the control group. The videos were analyzed like this. So we had basically 1 day per week of age that you see here. And then like this is the daily sampling pattern. So this is the whole day basically. And as soon as the lights went on in the morning, this was the firmest time per day. Then we had midday, that is basically like the middle of the light phase. Then the dusk phase, this is the time when the light is dimmed until basically the lights are off. And for the number of birds on the top tier, we actually had 15 minutes intervals that we took for each time per day. And then we counted on the number of birds that we saw on the top tier on the 1st, 8th, and 15th minute. For the number of transitions, we left out the lights off phase as we assumed that birds would not move as soon as the light is off. So we actually had 2 minutes counting continuously the number of transitions that we saw in these other 3 times per day. The statistical analysis was performed with the generalized linear mixed models in R. The explanatory variables were age, treatment, time of day, plus all interactions that included the treatment factor, and the random factor included was pen, nested in barn side, nested in flock. This is the first result. This is showing the result for the number of birds on the top tier. You can see that this variable was influenced or affected by an interaction between treatment and week of age. Oh, sorry. It's working. You have in red the pens with the ramps included, and in yellow the control pens. And as you see here, indicated by the stars, we found more birds on the upper tier of the aviaries and at the beginning of the observations. So in week of age 3, 4, 5, and 8, when the ramps were provided. Later at the end, or coming more to the end of the rearing phase, at 11 and 15 weeks of age, there was no difference in terms of the number on the upper tier. The same variable was also affected by an interaction between treatment and time of day. And this time you see here, as well indicated with the stars, that we found more birds on the upper tier when the ramps were provided, specifically during this dusk period, as well as the lights off, the dark period, with no differences in the other times per day. This is the result for the number of transitions. This was affected by treatment and week of age. And here in general, you see that overall, you see more transitions occurring when ramps are provided compared to pens that do not have ramps. I think this, specifically here at the beginning, when the birds are really still young, 3, 4 weeks of age, this difference is really pronounced. And then I also told you that we looked at whether transition was done with or without a ramp. So we could actually sum this all together and then calculate the percentage of transitions that were done with ramps. And this is shown here, plotted for the different weeks of age. And you see that at the beginning, nearly 100% of all transitions were performed with a ramp. And this is decreasing over age, but still at 14 weeks of age, over 80% of all the transitions that we observed in the ramp group were actually also performed with a ramp. So at this age, this is 4 weeks before they actually are moved to the laying hen house, they still prefer the ramps, even though they should be perfectly fine to, or are perfectly fine, I guess, to jump and fly these distances. So coming to the summary and conclusion. So we could show in the study that if we provide ramps for birds in aviary systems, that these birds would move vertically earlier and more compared to control birds. And this may have implication for the spatial and physical development. For example, we know, and we heard actually from Lucille and also from Alex, that if we provide the early opportunity for going to elevated surfaces, more complex environments, that this has a benefit in terms of cognitive task and abilities. And also we know that if you provide an opportunity for early exercise during the early rearing period, that this has an impact on the bone health of the birds. Secondly, we could show that if you have the ramps, that the birds actually had better access to resources. And this is specifically interesting for perches. We could see that the birds actually use the upper tiers for roosting during night much earlier and much more often compared to the control birds. That means by providing ramps, you also provide the ability for the birds to perform specific behaviors that the other birds simply don't have because they cannot reach these resources. And lastly, I think the preference for the ramps is quite clear. This has also been found in other studies on single tier systems. And it's, I guess you can conclude that it's specifically for rearing aviaries, it's very important to provide this a sufficient amount of ramps in these systems. They are difficult to navigate, but the birds clearly prefer them. And this is why it's important to put them in, I guess. So thanks for listening, and any questions.
Thank you very much. Questions? Yes, please.
Thank you, Ariana, for a really great talk. Very interesting. Anja Rieper from Aarhus University. I was wondering if you have any data on individual use of rams. Are there some birds that are just running up and down of the rams all the time, and others that we never see up, only a few times up?
Well, for this study, unfortunately not. I think really like Alex, what he presented at the beginning of the session, he really is like, from at least from what I know, is the first one looking into this individual use of RAM, but in the experimental settings. But I guess this is definitely a very interesting question. I think with future projects also planned in our group, this may be even possible that we can track birds individually also in large flocks. I mean, we are already able to do that. But for now, the focus has not been on rams, but I think this is definitely interesting because we already see the variation in these small pens. So I guess this is something that we can also transfer into to the bigger housing.
And we see the variation even without rams. So I was just
Exactly.
wondering if we have rams, do we get more of those that are not really using the aviary as much?
Perhaps even it would be interesting to compare, like having rams or not, because I guess if you don't have them, it's more difficult. So I guess the variation is bigger. And if you put in rams, that perhaps it gets more equal because the ones that are not able to go up are able to go up then with rams. Yeah, that's an interesting project idea.
Okay, we have probably to proceed because we are a bit delayed. And our next presentation is online and it's by Sarah Forslind. Sarah, can you hear us?
Hello. Yeah, I can hear you. Can you hear me?
We can hear you too. So please, you can start.
Yeah, thank you very much. So sorry I couldn't join you this time, but I've been sick. So I'm very grateful to be able to give this presentation online instead. And I'm going to talk about the resting behavior of broilers that are reared with or without artificial brooders. And for those of you who don't know what brooders are, I will tell you soon. But first, it's very important to know what sleep is, and that is very important for both mammals and birds. And sleep serves very important biological functions and is important for the welfare of animals. But it's difficult to measure in the birds. And to measure it, we need an EEG on the brain to measure the brain activity. And instead, we differ the rest and the sleep. And our definitions is then that the rest is a period of inactivity and that the birds don't perform any maintenance behaviors at that time. And sleep is the specific state of inactivity with altered consciousness. And to introduce that to the broilers, Sigga gave a very good presentation of the broiler production. So I'm just going to say that there are large flocks and in large areas, and they grow very, very fast. So in these settings, we have a lot of welfare issues, like, for example, health problems and impaired locomotion and behavioral restrictions. But when we look at the welfare issues, sleep and rest are often not considered in this context. So when we look at the resting behavior in broiler chickens, we see that there are like a pattern of activity and resting behavior of the chicks, and that all individuals have different patterns of this activity and resting behavior. And this is probably because there are no cues of the mother hen, and they are in this setting with high stocking density. They have a very barren environment and a lighting schedule that doesn't really fit with what they're used to in the wild. So what we see is a desynchronization of the chicks in the group, and that leads to disturbances between the birds in each pen, and the resting birds are disturbed by the active. So what we know about resting behavior in broilers before are that they have bouts around 45 minutes, which is the mother hen will synchronize the chicks. So she decides when they are resting and when they are active. And chickens generally avoid open areas, both in the pen, in the production settings, and while resting, because in the wild they often rest elevated in trees. And we also know that disrupted rest have negative effects on welfare. So therefore, our aim of this study was to investigate the functions of a separate resting place. And we think that this separate resting place in the pen could provide opportunities for long and undisturbed resting bouts. So we used the mixed sex Ross 308 broilers, and we had these artificial brooders, which you can see on the picture, which is a heated plate with heat underneath. And then we put some flaps of tarp around to get the dark area underneath. And these can be adjusted in the height to follow the growth of the chicks. So we used the 12 pens of 7 square meters, and half of them were provided with these artificial brooders that you can see in the picture, and half of them were controls, and they did not have any brooders. And what we did was to video record the pens, so the behavior of the birds, and we placed a camera above each pen, and we also placed the small cameras under the brooders to see the behavior of the birds under them. And what we looked at was duration of resting bouts, and also where the chicks were resting in the pen. And we observed the disturbances and also motivation to continue resting by looking at the duration of the activity after each resting bout. And we observed the behavior at day 20 and 34. We also did a spatial learning test, but we didn't do it for the cognition of the birds, but rather as an indicator of fragmented sleep. Because we know that from rats, if they get fragmented sleep, which is when they are disturbed several times during a night, they're not allowed to sleep long enough. They perform worse in spatial learning and cognitive tasks. So we used 30 chicks per treatment at 11 days of age, and placed them in this start cage that you can see in the picture, and then just recorded the time it took for them to leave the start cage. That means that they had to back off and around the corner. And then we also took the time until they reached the companion cage, and we also looked at how many chicks solved this within 10 minutes. So when we come to the results, we see that the chicks in the treatment with the brooders, they had longer resting bouts than the control treatments. And it's almost twice as long for the mean values of this. But we can also look at the where they were resting. And we saw that the resting that took place under the artificial brooder were longer than resting that were taking place in open areas or near walls. But that the duration of resting bouts near walls and in open areas did not differ from each other. And then we looked at the proportion of disturbances for the birds that we looked at the resting bouts. And we can see some differences in how many birds were disturbed and ended the resting bout. So in the treatment with brooders, there were 15% that were disturbed, and in the control group, it was 48% at 20 days of age. And at 34, it was also lower in the treatment with brooders, where 25% were disturbed, and in the control, 42%. I also looked at the resting bouts in between the groups according to the disturbances, and resting bouts of disturbed birds were shorter compared to the resting bouts that were not ended by a disturbance. And also, when we looked at the activity after the resting bout, the activity to start when they started resting again, we saw that the activity was shorter if they were disturbed. And we looked at the spatial learning. We saw differences in how many chickens solve the spatial learning test. So half of them with the brooders, but only a fourth of those reared without brooders. But however, we couldn't see any differences in the latency to reach the companion cage or to leave the start cage. And there are several reasons to why this happened. But since we use it as an indicator, we think maybe it could also be that they learned, being with the brooders, they learned that they could move around stuff to get to the companions. So that might be one thing playing with these results. But to sum up, we saw a lot of disturbances in general in both of the treatments. And when we looked at the duration of resting bouts, they were generally very short, up to 10 minutes, and they were highly affected by the disturbances. So a lot shorter if the bird were disturbed. But we could also see a high motivation to continue resting after an ended resting bout. And this might mean that they experience some sort of sleep deprivation. But since we cannot measure the sleep without an EEG, we can't really say what will happen with the sleep. But we see, since we see this in the resting, there might be a future study to also look at the sleep. But we can say that sleep and rest could be seen as a welfare issue for the broiler production. And to conclude, the separate resting place we used provides the opportunity for less disturbances and longer resting bouts, but it's not enough. So to eliminate the disturbances, there is something more that needs to be done. And thank you very much. And I just wanted to say that this study was published this summer, if you want to read more.
Thank you, Sarah. Questions?
Sabine Gebhardt from University of Bern. Well, thank you. Yeah, I also think these artificial brooders are great, but you mentioned a little bit about temperature, but not very much. So I would like to know more about it, because if you want to simulate natural hen, then you would have this temperature gradient underneath the hen. It would be much warmer, and then on the rest of the barn it would be cold. And so maybe you then would even get more of a stronger result or a stronger difference. And also maybe you could save energy by lowering the barn temperature and concentrating on heating those artificial brooders. So you could have both improve the behavior and the resting, and maybe also save CO2.
Yeah, well, thank you very much for the question. I didn't mention that, but we had different temperatures in the barn. So the control group had higher temperatures starting at 34 degrees. And for the brooder treatment, they had a separate place in the barn. So we started with high temperatures under the brooder, and I think we started with 20 degrees in the barn. So it was colder in the barn, so that the brooder should be more attractive and be more like a brooding hen.
Bas Rodenburg, Utrecht University. Thanks for a very interesting talk. Yeah, my question actually follows up the one from Sabine, because we worked with a Dutch farm that actually moved in this direction of also changing sustainability, energy use, etc. And it might offer us a solution for your point in the conclusion that we need more, because this farmer, he combined a different form of dark brooder, not with the curtains, a bit more open, etc., but with platforms for the broilers to rest on. And both were used quite extensively, and he saw really positive effects. And we did some studies on behavior, and they also fit with your findings. So can you comment on that, the combination with platforms?
Yeah, absolutely. We looked at platforms in another study, and we can also see that the platforms affected rest. So birds resting on top of platforms rest longer and get less disturbed. So a combination of these is definitely something we could try in the future.
Any other questions? If not, we have to proceed. And our last speaker is Jenny Straka.
Yes, thank you. Hello, my name is Jenny, and I'm from the University in Bonn. And the study I'm presenting today is part of the PhD thesis of Alisa Krasny, who unfortunately can't be here today because she's on maternal leave, so probably fits quite good with her topic because she's interested in maternal effects in turkey chicks. And the work done in this study was mainly done by two students, Lea and Moritz, both of them unfortunately not here as well. So I did not do much work in the study, but hopefully can present the results quite worthily. So it's all about maternal care in turkeys for this talk. And when we look into wild turkeys, maternal care is quite important. Offspring and the mother hen spend quite a few time with each other, so up to 4-6 months at least, but mothers and daughters can stay together for several years. When we look into turkey production, maternal care does not play any role. So normally chicks are, normally we have artificial hatching and rearing. So chicks come from the broodery or out of the incubator and then are raised without the contact to an adult animal for all of their lives. What we know from laying hens or from studies in laying hens is that the mother or at least an adult animal can have quite positive effects on the behavior of the chicks. So we know that it has positive effects on activity, affective state, learning, cognitive abilities, and so on. But we know nothing in turkeys yet, as so often we have little studies in turkeys. So the aim of the study was to look into this early postnatal period to see if we have any effects of the mother or indeed an adult animal on the behavior of turkey chicks in an open field novel object test. And what Alisa did was that she provided two rearing systems. So rearing system 1 would be the artificial rearing. Chicks here are brooded and hatched in the incubator and raised without an adult animal. So this is the normal standard procedure which we have on turkey production. And she also provided a second rearing system 2. She called it semi-natural rearing. And here chicks were brooded in the incubator as well, but then hatched under the foster mother. And we did this by tricking the foster mothers. So the broody hens were provided with warm potatoes when they were broody. And then shortly before hatching of the chicks, we kind of took them the potatoes and smuggled the eggs under the foster mothers. And then chicks hatched under the foster mother and were raised with the presence of the adult animal. The study was performed on an organic farm, so all animals were raised under German organic standards. And we had quite a mixture of breeds. We had some Kelly turkeys, but mainly we had a mixture out of Hockenhol, which is a hybrid line used in organic farming, and an old breed, which were Kröllwitzer and Ronquiers. As foster mothers, we had the Kröllwitzer turkey because they are known to be quite good mothers. All animals were in the same stable. We had different pens. Unfortunately, we had a variable group size according to the quantity of chicks hatching, but we tried at least to keep the stocking density stable with providing 16 square centimeters per animals. And we provided food and water ad libitum. And in rearing system 1, so the rearing system without the foster mother, we provided additional heat lamps to ensure that temperature was all right for the chicks. We didn't do this in rearing system 2 because there the foster mother was supposed to do this job. So we looked, or Elisa looked at the rearing period, which was 8 weeks. And then after that, animals went to different farms for the fattening period. And we did a bunch of behavioral tests. So we did group tests, tonic immobility, social confrontation. But for today, I will focus on the open field novel object test, which was done twice. So first when animals were 6 weeks old, and the second time was done, the test was repeated when animals were 8 weeks old. And altogether, Alisa looked at 8 rearing periods with 10 focus animals per rearing system for each of those rearing periods. So in total, we had 160 animals, 80 for each rearing system. This is the theory. We ended up with around 70 and 60 animals for week 6 and 8 because we lost some of the chicks during the study. And with those chicks, each animal was tested individually in an open arena, which measured 2.5 square meters. And the behavior was observed by video recordings for 10 minutes. And additionally, we provided a novel object after 5 minutes, which was like decreased from the ceiling. So the animals were not disturbed by a human being. Leah and Moritz did all the behavioral recording, so we did quite a good job doing the behavioral analysis and observing a bunch of behavioral parameters like walking, standing, resting. We measured flight attempts, pecking, wing stretching, and also the position in the arena. So we divided the arena into 9 quarters or quadrants, and just to get an impression how the animals used the space they had. We also measured vocalizations, but I won't present results for this one here because there's a bunch of data which we haven't even touched yet. Yeah, this will be done in future. We calculated generalized linear mixed models. Using the rearing system, the week of life, and the interaction as fixed factors, and we use the individual nested and pen and rearing period as a random factor. Coming to the results. So here in blue, you see the chicks or the results for the chicks of rearing system 1. So the rearing system without a foster mother, and in green, results for rearing system 2. And we found a significant effect in walking and standing. So chicks of rearing system 2 walked more and stood less. And we saw this effect of activity as well when we looked at the amount of changes in quadrants. So here as well, chicks of rearing system 2 changed quadrants more often than chicks of rearing system 1. What we found as well for this parameter is an effect of age, or more likely the test repetition, I think. So when tested the second time in week 8, animals showed more changes of quadrants than when tested the first time. This effect was also present when we looked at the latency to the first step. So here again, animals showed a decrease in latency when tested the second time. So I think this might be kind of a habituation to the test repetition. Might be the age as well. I'm not too sure about that. Apart that, we found no significant differences, and we found none of our animals interacting with the novel object, so neither of the rearing system 1 nor of the rearing system 2. But I brought this colored graph as well, not because there are so many funny colors in it, but because it shows quite good how variable the behavior was in all the chicks we measured. So these are the number of flight attempts, and each color is presenting one animal. So as you can see, there are some animals showing quite a lot of flight attempts, some animals showing it only once, and there's a lot of animals don't show this behavior at all. So we had that for the different behaviors we measured. So there was quite a variability in behavior. Okay, to sum up, we found that chicks raised with the foster mother were more active. So they had higher duration in walking, less standing, more changes of positions. But we also found an effect of the test repetition or the age, which was obvious in the latency for the first step. I'm a bit, to conclude, I don't want to put too much into these results yet, but I think these results show quite good that the early postnatal period might be quite important to look more into detail at in turkeys as well, because we have effects of the behavior, and looking at the other tests we make, we find kind of the same direction. And so I would encourage you to do more into this topic, because I think this is quite important, at least if we heard the talk of Sarah already about the artificial brooding. So I think in turkeys as well, this might be a good way to go in the future. And with that, I'd like to thank the project team and you for listening, and I'm happy for questions.
Thank you very much. Questions? Yes, please.
Oluwaseun Yasiri, Humboldt University. Thank you for the wonderful presentation, but I would like to ask you, did you check any home pen observation? Did you do any behavioral observation in the home pen with the mother turkey and the poults? And secondly, sorry, you talked about this habituation issue, that when you tested the second time, there was a difference, but at these different times, was the result similar? Was the trend similar for the mother reared and non-brooded?
Yeah, I will answer the second question first. Yes, the trend was similar there, but it was not that obvious, because the chicks of rearing system 1 as well, they were more active there as well. So it wasn't that pronounced, but the difference was still there. And for the first question, yes, we did home pen observations as well. The analysis is still going on, and unfortunately probably will take some time, because at least I will have other things to do now. But yeah, we want to look at the synchronized behavior there actually. This is the main focus of her study, to see for the daily rhythm how mother and chick interact with each other. So that's the focus there, but I don't have any results yet.
Other questions? Yes, please.
And thanks, Jenny. Bas Rodenburg, Utrecht University. I was wondering about in laying hens, there's evidence for reduced fear in birds that were reared with a mother. Did you do any fear tests, and did you see any effects there, if you did?
We did the tonic immobility test, but the problem there was that all of our chicks of both rearing systems went up in the first second, under the first second. So they are not, this is not quite a good measure there, because we can't really measure differences, because they were so fast, all of them. We had group tests as well. They as well were quite difficult, because we did a novel human test, novel object test, and none of our chicks were interested in anything. So neither of both rearing systems. So we only have the open field novel object test as a field test, and then as I said, like Zika, what's the name, said already, might be not that good standing on its own. I am hoping a bit for the vocalizations, because there we want to look into the quality of vocalization, and I hope to see there's something going on. But yeah, I think this will take a while because yeah, I'm not able doing it on my own. So probably if someone wants to do vocalizations, we have a bunch of data. So.
I have a question. Did you observe some inter-individual differences in behavior of fostering mothers? Did they cooperate in a similar way, or there were some differences in their willingness to do that?
We didn't do the behavior test with the foster mothers. This would have been cool, but I was not thinking of it at that stage. But I hope to see a bit more in the home pain observations, because they were quite different. They all were they all did their job quite good, because they all were in the first year. We had pre-studies before, and there it was a bit complicated because the foster mothers were quite young, and there we had some being quite, I don't know, confused by the situation, but I would guess that there are individual differences. And I think this was the talk yesterday on the effect of the mother on, I think it was calves. So I think there's something there as well.
Thank you. One more question, please.
Why did you not let them incubate the eggs? Were you afraid that this would also introduce variation, or why did you have the eggs artificially incubated and let those broody hens sit on potatoes?
That was mainly the reason because we had those different breeds, and like the question Lubin just said, I kind of thought that the different breeds might have complete different mother abilities. So the Cali turkeys are not known for their motherhood, for example. So we wanted to have this stable, and it had practical reasons as well, because this study was part of an agricultural funding, and the focus of the funders was more on the different breeds used, or they wanted to use different breeds. We didn't do this in the end, but when we made the study design, we had the idea using different breeds, and then to get the eggs of the different breeds using in the test design, and it would not have been possible to have the same amount of eggs at the same time. So this was more a practical reason then.
Thank you very much once more. And now it's time for poster presentations. Please, poster presenters, it's your turn.
Hi, my name is Katie Broekmeulen. I'm a PhD student at the University of Bern, and on my poster I'm presenting some results of a pilot study on effects of individual hatching system factors on stress responsivity in laying hen. For this pilot study, we've selected several environmental factors, such as light exposure during the last phase of incubation, feed and water access, and litter access post-hatch. And we want to investigate how these factors affect the behavioral development of laying hen chicks. So if you want to find out more about on-farm hatching or a step detour test that we used in the study, please come and talk to me. Thank you.
Hi, Anja Šironik from University of Veterinary Medicine, Vienna, Slovenia, Austria. Sorry about that. Dark brooders are successful in preventing feather pecking and cannibalism, but we don't know why. And as we heard before, dark brooders can separate resting individuals from active chicks. Thus, we hypothesize that general activity outside the brooder would be reduced in dark brooded chicks compared to non-brooded individuals. And to test this hypothesis, we provided some chicks with brooders and the others had no brooders. And we also checked whether brooder size and lifting the brooder in the first days affects activity level in chicks, in pullet chicks. And if you want to know more about the study design and the results, please see my poster 116. Thank you.
Hello, my name is Maya Makago, and I'm from UC Davis in the United States. And I'm pleased to present a poster that was work completed by Dr. Lindsay Brodus as part of her recently completed dissertation. So in the US, ducklings are usually reared, especially ducklings that are meant for egg production, are usually reared in same-sex groups so that we can support different growth curves. But sometimes farmers will place just a few female chicks into the otherwise all male pens. The idea being that this will promote reproductive development and overall flock fertility. However, this assumed relationship has not been tested, and therefore that became a large part of Lindsay's dissertation. So, does physical access to female ducklings during rearing promote the reproductive development of drakes and improve flock fertility? If you'd like to find out, come see me at poster 117.
I would like to thank all the presenters, all those who contributed to the discussion, and all of you for coming. And this session is closed, but there is one more announcement.
Yes, this is a surprise speech, but it's about the lunch, so it's important. For those of you who don't know me, I'm Saskia Kliphuis. I'm one of the student representatives of the ISAE, together with Rachel Cadell. And we are organizing activities for students during this Congress. But now during lunch, we have the final activity, and that's actually not only for students, but for everyone. So we want to invite everyone to join the table topics during lunch. So we prepared topics to discuss on the tables, both inside and outside at the lunch area that you already know. Yeah, it's a nice place to interact, for students to interact with the more senior attendees. And I'll just quickly tell you the 10 topics that we have so you can think about your favorite topic on your way to lunch. So it's social behavior, abnormal behavior, cognition and emotion, pain, play behavior, technology and welfare, euthanasia, education in welfare, welfare policy, and human-animal interactions. Have fun.